question 7, question 8, question 20, question 2. Okay. All right. So question 1, and there is a second attempt, so you can definitely go back. 1, 2, 3 lines of symmetry from corner to corner, and then 1, 2, 3 lines of symmetry from side to side. So this has 6. The triangle can go from corner to side, corner to side, corner to side. That's 3. They can also rotate. So these guys can both rotate. The parallelogram is the most often asked question. You want to be able to slice it in some kind of way. You cannot. There is no way to slice a parallelogram. You can put a pin in it and rotate it 180 degrees though. So this one is rotational only. Okay. The scalene triangle has nothing in it that's the same. So that's nada. Can't do a thing with that. The star, we can go 1, 2, 3, 4, 5. Boom. Okay, 10 is a tempting answer for that, but the answer is 5. For number 2, I can slice the moon in half, but I can't rotate it. If I rotate it 360 degrees, it's like I haven't moved it at all. So 360 is not an okay rotation. So this one's line symmetry only. And the radioactive symbol, I can slice in 3 different directions, 1, 2, and 3, and I can rotate it. So it's both line and rotational. Let's get another color. This little guy, I can rotate it 3 times, right? So that's rotational only. Boom. And then this weird trapezoid, this right trapezoid, this guy is 0. Okay. Questions on that? Okay. Any questions on number 3? We good with that? 4? This is the order it should have been in. Boom. 5, we're just going to go left and down. So we're going to take all of those points and go left 3 and down 4. Use Desmos if you want to or need to. Download or add on the extension Screencastify, and then on your test you can plot. Okay, that's kind of the best we can do right now with the tools that we've got. How has this been transformed? So the key is to go from the Q to the Q prime, or from the P to the P prime. Okay, start at the one without the tick mark and go to the one with the tick mark. Number 7 was one of our questions. So all I'm moving is T, and it's going to go off the graph. So I want to go 4 units down. So it's going to go 1, 2, 3, 4. So it's going to end up at -8. So that's going to be -1, -8, I think.
Start with the one with the tick mark?
Without the tick mark. So you're going to go from Q to Q prime. So you're going to go down 7 and right 1. Down 7 is the Y, and right 1, that's the X. You're welcome. Number 8 was one of our questions. So we are reflecting across the x-axis. Highlight your axis, guys. So many people know how to do this kind of question, but they flip over the wrong axis because they don't highlight it. So I am going to expand my screen just a little bit because that is so hard for me to see. And I'm going to go 1, 2, 3, 4, 5. And this 5 above the line. So I'm going to go 5 below the line. 1, 2, 3, 4, 5. The X is going to stay the same. So it's still 1, 2, 3, 4. But now it's a -5. Because I flipped over the X stays the same and the Y changes. Okay. How about question 9? We good on that? Let's do the y-axis. Oh, that wasn't on the y-axis. When you flip over y equals x, because y equals x, x equals y. So these points just flip-flop. Those points just flip-flop. So C prime is going to be -9, 3. Literally, my x and my y just change places, right? How is this one different? What does the line y equals -x look like? It does go through the origin, and it goes in a negative slope, right? So here our x's and our y's are going to flip, but they're also going to change sign because I've got that negative right there. So the only point I care about is D. The only point I care about is D, so I need to know what that point is first. That's 4 x's and down 3. So that's 4, -3. It's going to flip across this purple line to the other side, and all I'm going to do is flip these and negate them. So D prime is going to be +3, -4. Okay, you switch the sign and negate them because of that negative sign right there. Here, all we care about is W. So plot W, use Desmos. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Or Screencastify. We're going to rotate 180 degrees. So that's 90 and that's 180. Or that's 90 and that's 180. They're going to land in the same spot. So if I switch and switch back, it's still a 6 and a 7. And it's landed here in quadrant 4. So it's got to be positive, negative, because I went to the right and then down. So +6, -7. That's kind of how you think through those. Okay. And you're going to have to write down stuff. You can't do this without. Same thing here. I'm just going to do a couple of points. I'm going to do J and K, not everything. If I go 1, -3, and 5, 1, 2, 3, 4, 5, 0. Man, it starts to make my eyes go crazy. I'm going to go 90 degrees counterclockwise. So the axis is going to go to the y-axis. So I'm just going to switch them one time. 5, 0 becomes 0, 5. This one is going to come up here, and it's going to switch and become positive, positive. So the 1, -3 is going to become 3, 1. Okay. We've done a couple of rotations. I don't want to do another one, but basically the 270 goes 3 quadrants around. So you switch, switch, and switch back, right?
Wait, I have a question.
Okay.
So for number 13, it went before 8?
It is going to be 4, 8. Because these guys switch to 4, 8. It shouldn't be this one because this point should be 7, 4. And that was the one that I wondered whether if you checked it or didn't check it, if it marked it wrong. Because the answer key was wrong. I changed it, but I don't know if it updated. So it should be these 3, but not this one. Does that make sense?
Yes.
Okay, you're welcome. So 270 is 3/4 of the way around. Which transformation does not preserve the dimension? Which one should you not choose? So if I translate, I take a shape and I just move it around to a different spot. Is it the same size?
Not dilation.
Not dilation. Perfect. So dilation is not going to work. Translations stay exactly the same. They are all congruent. Rotations are all congruent. Reflections are all congruent, but dilations are similar. They get big and small. So when I translate something, right, I slide it around, what stays the same?
The figure of the shape.
The figure, right? So the side and the area, but the coordinates change. Okay. We've done rotations. I think the next one we wanted to talk about was scale factor is good. Question 20. So identify the scale factor used. We want to start at the original point and go to the new point. So is it original divided by new or new divided by original? Wasn't it new divided by original? So this W prime point is negative 8, 8. And the original W is negative 2, 2. So if I do that division, negative 8 divided by 2 is 4. And 8 divided by 2 is 4. My scale factor is 4. Okay. The second part of that question is distance. Just because we learned that a couple of units ago doesn't mean we can ignore it. So what I do is I draw that slope triangle, right? This is the easiest way for me to do it when it's on a graph. I've got a 2 and a 4, and then this is the hypotenuse, that's C. So 2 squared plus 4 squared equals C squared. You can also use the ordered pairs and use the distance formula. X minus X squared plus Y minus Y squared. I'm running out of room. Okay. But for the distance, you'd get 2 squared plus 4 squared, and then remember to take the square root of that. Does that make sense for the distance? Kind of, sort of, maybe. You can do the same thing for W prime, X prime. Make that slope triangle and count. I've got 1, 2, 3, 4, 5, 6, 7, 8. All I'm using is Pythagorean theorem. This is a right triangle. So then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I had a scale factor of 4. These are 4 times bigger. So that kind of makes sense, right? So then my Pythagorean theorem problem down here is the square root of 8 squared plus 16 squared. And then the directions say round to the nearest tenth. Okay. We good with 21?